Okay, I'm trying to talking about the reverse engineering concept or reverse engineering topics หรือบางทีเราภาษาไทยเรียกว่าวิศวกรรมย้อนรอยอะไรเงี้ยนะฮะทีนี้ I would like to give you some summarize of this technique first. Okay, so what does it mean by what is mean by reverse engineering? Sometimes we call concept or sometimes we call it technique. Let's say the problem is like when you do 3D surface design. Typical, normally this technique is quite difficult to, if you want to create 3D surface model, surface designs, typically it's very difficult actually, difficult to create. Because you see, to obtain surface, you need 3D point. And point you need 3D profile, right? And from 3D profile, you can generate complex surface, right? You can use this one. This is a typical, that makes, the problem is to assign 3D point or 3D profile, many 3D point first. It's very, very difficult or not convenient if you work on flat screen, right? So you have to have some another way around to actually to help you to generate 3D point. It means that in this case, as I mentioned previously, we have a 3D digitizer. So 3D digitizer is a device, is a machine. For example, CMM. CMM, as I mentioned previously, CMM is coordinate measuring machine. It actually, the main purpose of this machine is for QC, quality control. Quality control. The typical, I mean, the main purpose of this machine, they build the machine to actually to do quality control. Let's say if you build, if you machine a part like this one, and you have some tolerance control. Let's say you have dimension this one plus or minus. This we call it tolerance. This kind of tolerance, as well as this one as well. You need to have some tolerance as well. Even this one. So this is the one that you need to control your production. Okay. When you build this machine with the part, before you send to your customer, actually you need to do some QC, quality control. So CMM is a machine that help us to do some like quality control of your machining part. And CMM is the technique is like a 3D digitize, right? It's like a 2D digitizer, as I showed you before. This one. Let's see. See, you have digitized this one. Digitize, or this is a manual CMM, right? This is a laser scanning CMM. This one is combination with laser line and the camera that we use to, you can digitize point along these laser lines. This is the main basic function of this one. So you see, you can control distance between laser head and surface. In that case, you can digitize surface coordinate, right? So this is a typical CMM machine. This machine we built by ourselves. This one is like a manual CMM. This one we bought. This one is I mean, there are many model, many type. So you have point, something like this one, as mentioned previously. So once you have points, I mean that point is you need to do some filterings. You see, when you measure a point using laser or using some force, you see, you look at this one, right? You place this, and because the accuracy here is very accurate, it's like 2 micron, 5 micron anyway, which is very, if you touch with different force, you have your lead out is different. So something like this one. So you need to use some filter command that began filtering this point, and this point can be helped to generate surface of this one. Okay, so you see this one is like we call lever engineering. You see, you have part like this one. You can digitize points along these objects, right? You can filtering out, and you can get surface this one. Okay, so this is a typical lever engineering technique. This point we call cloud point เป็นเมฆของจุด Normally it's quite a lot. As I showed you previously, you see you have this one. You can digitize and you pass into some filtering command, and you can obtain surface, something like this one. So it's called a lever engineering technique anyway. So in this case, you see, you need to have a model. You see, you need to have the model first. So this model maybe come from CAE model, or you have some, let's say, typically you have, because you have a industrial designer, this person can design very complex surface. Let's say this one, this normally do product design. It's especially enclosure outside, right? So industrial designer typically they just design outside. Maybe they normally come from 2D. Industrial designer come from 2D, or 3D perspective. For example, like this one. You see, normally it comes with they sketch, stylists, they sketch the model, and after that, after you have this 2D 3D perspective view, this one, you need to have CAE modeler. This is a person who will convert this into CAE model. Something like this one, CAE models. And after that, if you have this CAE model, you just use CMM or digitizer, 3D digitizer, so you get cloud point. So this cloud point can be used to generate profile as well as to generate surface. Something like this one. See, you have a cloud point you passing to point processing. After you have point processing, you see, called point passing to point processing. After that, you get polygon model. polygon model นี้เป็นโมเดลที่หยาบนะเรายังไม่ได้ใช้ยังไม่ได้เป็น surface สุดท้ายของเราwe call polygon model ไม่ใช่เป็นสุดท้ายหน้าตา you typical you see very rough หยาบผิวหยาบนะเพราะว่ามันเกิดจากอะไรฮะ we create based on like we connect 3 point เราเชื่อม3จุดเนี่ย to form a small surface right small rectangular surface and those all connect each other to have this type of surface ผิว surface อันนี้มันเป็นผิว surface ที่ไม่ค่อยอะไรฮะยังไม่ละเอียดแต่มีประโยชน์นะครับเพราะว่าจาก this one from this polygon model is something like a solid it's like surface and solid inside your computer you can actually digitize point พวกนี้ได้สมมุติผิวนี้ไม่เรียบนะสมมติผิวนี้ไม่เรียบแต่คุณก็สามารถ digitize point บนอันนี้มันอยู่ในคอมพิวเตอร์เพราะฉะนั้นถ้าอยู่ในคอมพิวเตอร์เนี่ยคุณก็สามารถเอาอะไรฮะเอาเมาส์ไปฮะไปคลิกไปอะไรฮะไปอ่านค่ามัน you can use mouse to actually to read coordinate let's see read coordinate on that right ถึงแม้มันจะเป็นไม่เรียบนะแต่เราสามารถเหมือนกับเป็น object อยู่ในอะไรฮะคอมพิวเตอร์เราก็สามารถดิจิทัลใช้เมาส์เนี่ยดิจิทัลเข้ามาได้นะเหมือนที่เมื่อกี้ที่ผมI give you last week you see you have mouse profile right you see mouse first of all I have a model mouse model first and the digital you get point and point we use that point we generate a profile right and this profile you generate surface เพราะฉะนั้นถึงแม้เรามีโมเดลนี้นะดูดิ mouse model we have point right in this case you see in that point we can point but in this case same right you have point you can actually generate polygon model ในกรณีที่รูปร่างเราคอมพลีเคทมากเช่นเมื่อกี้ให้ดูแล้วรถยนต์เนี่ยนะเราได้ point มาเยอะเลยใหญ่เลยนะแต่ละ point เนี่ยก็สามารถมา generate ได้เป็น polygon model เหมือนกับเป็น object ในแล้วคอมพิวเตอร์ใช่ไหมแล้วหลังจากนั้นเราก็สามารถดิจิทัลได้แล้วเราก็มาสร้างเคอร์ฟได้สร้างเส้นสร้างเคอร์ฟได้เดี๋ยวให้ดูต่อเมื่อกี้ที่เราให้ดูนะ this one see this is a polygon model แต่ว่าอันนี้เหมือนกับ object อยู่ในคอมพิวเตอร์คุณเอาเมาส์ไปแตะมันคุณก็ได้จุดถึงแม้มันไม่เรียบนะคุณได้จุดมาไม่เรียบก็จริงแต่คุณผ่านคอมพิวเตอร์เดี๋ยวมันจะเรียบเองนะเนี่ย polygon สิดูอันนี้ดูนะดูต่อนิดหนึ่งนะเราได้จุดมาใช่ไหมจุดอันนี้ this point is we call cloud point come from what come from CMM this one come from CM or sometimes we call typical 3D digitizer there are many type of 3D digitizer I will show you later on okay I show you just some very classic one. There is a modern one which can be generate this point much faster. Okay, so you get this one. You see, you have point. This is called cow point. มีจุดเป็นหมื่นนะนี่หลายหมื่นจุดนะเนี่ยบางครั้งเป็นแสนจุดนะ It's very huge model anyway. Okay, so you have a lot of surface here. After that, you pass into some filtering. They filter some point to minimize necessary points that need for create 3Ds. Okay, so look at this video. After we have the points, we can actually limit working point. We can select this one. We can select some point that we want to working on จุดมันมีเยอะใช่ไหมเราสามารถเลือกเป็นจุดๆได้ว่ากลุ่มนี้เราจะทำก่อนกลุ่มนี้จะทำทีหลังนะฮะได้นะเฉพาะบางจุดโชว์มานะ and this one we can use to generate surface anyway okay see okay you see this is the generate automatic generate เลยมันสร้างเองนะสร้างให้เรามีคำสั่งเดียวปุ๊บมันสร้างโพลีกอนให้เราเลยโพลีกอนรูปนี้เป็นรูปหยาบ it's very large model you see very large but it's like an object in your computer it's like object in your computer so you can use mouse to actually digitize point along this surfaceมันเป็นเหมือนกับโมเดลในเทมเพลตในคอมพิวเตอร์ของเราอะเราก็มาเลือกจุดบนนี้ได้แล้วพอจุดบนนี้เราได้จุดมาเนี่ยเราก็มาสร้างเคอร์ฟได้เนี่ยเราได้เส้นมาเนี่ยนะฮะสามารถเลือกเป็น cross section ได้ we can choose something like there are some tool that you can select like something like this one is a cross section profiles something like this one so this is a points along that cross section and you see you can smooth this thing out yeah you can get smooth this thing out you see so you have very smooth curve now for this one ผมไม่ได้สอนเทคนิคผมดูเดโมให้คุณดูนะเทคนิคอันนี้มันใช้เวลาเยอะเหมือนกันนะในการที่จะฝึกมันนะฮะนี่ทำให้คุณดูเฉยๆนะ you see you have this point along this laugh contour right and you can actually generate a smooth curve from this one you see remember degree of curve มันมีจุดเยอะๆเราสามารถเลือกจุดแล้วเราสามารถนะฮะบอกว่าจะเอา degree of curve เท่าไหร่จำได้ไหมครั้งที่แล้ว we said degree of curve is equal to number of point minus 1 okay if you have higher degree of curve it means computation maybe take a bit longer okay so you look at this one we can actually we can divide this a high degree of curve to smaller degree of curve to have more than one profile anyway you see we can digitize ใช่ไหมเรา digitize จุดบน polygon model ใช่ไหมเอาเมาส์ไปจิ้มจุดนะแล้วจุดพวกนี้เป็นไงฮะเราสามารถสร้าง smooth curve ได้เราสร้าง smooth curve บนนี้ได้สร้างเนี่ย smooth curve นี่เรา digitize เหมือนกับมีของมันมีรถผิวอยู่เนี่ยเหตุที่เรามีอันนี้ไปรูปร่างอันเนี้ยรถอันนี้มันใกล้เคียงกันแล้วของจริงit's very close to the real one right even is from the K model anyway yeah see this one we can use a few command and we can obtain all the age I mean every age we can obtain profile ทำเหมือนกันเนี่ยแล้วก็เราก็ได้แล้ว profile มาใช่ไหม this profile is a 3D and the compact profile anyway this profile we can actually generate surface the green one this one is rather smooth it's a smooth surface compared to the orange one is a polygon is not smooth this one is smoother see we use a few command นะทำแล้วอาทิตย์ที่แล้วผมสอนที่การทำ fill command ใช่ไหมเรามีโปรไฟล์สามารถเลือกได้ fill command เนี่ยมาแล้วก็ทำเรื่อยลองไปเรื่อยๆเนี่ยเราก็ได้ผิวออกมา เราก็เปรียบเทียบได้นะจากผิวที่เราสร้างขึ้นมากับผิวของอะไรฮะของ polygon model เห็นไหมมันไม่เรียบ polygon model ไม่เรียบมันก็จะมีบางอันสูงต่ำอ่ะแต่ว่าอันที่อะไรฮะเรียบคืออันเนี้ยสีเขียวอ่ะนะเหลืองเขียวเราเลือก point เราจะให้ generate you see this polygon right and we select this one use a few command see and compare to the polygon this is okay so we just accept it we do the same for all the whole body in this case we just do only half of them and we can mirror to the other half see you can do the other side the other one as well you see we just select point there are some detail if you want to do this digitizing technique there's still some model some detail that you need to understand it's just a demonstration how to do it that's all see you can select point and generate surface this is something like a template that you used as a reference and compare to the one that you generate from this one is like a few command but inside this module we call power fit command you see so you have this one and you can compare to this one this is a program model right so it looks like it's okay so you can accept that one yeah เราก็ทำไปเรื่อยๆนะเชื่อมต่อไปเรื่อยๆนะ โอเคหลังจากนั้นเราก็ได้เป็นอันนี้ก็เรียกว่า surface model แล้วนะ we can use this one to whatsoever as a dowsing application โอเคเป็นไงฮะเข้าใจป่ะฮะโอเคดิสิหลังจากเนี้ยอันนี้ก็คือเทคนิคอะสมมุติเราอย่างที่ทำเนี่ยนะเราได้เป็นจุดมาเราสร้าง surface นะฮะแล้วก็มันจะเรามา generate surface ทีหนึ่งนะให้สวยขึ้นมานะทีนี้ผมขอไปตัวอย่างนิดนึงนะให้ดูตัวอย่างนิดนึงนะI would like to show you some like we using least reward engineering product เดี๋ยวไว้อาทิตย์หน้าดีกว่าเดี๋ยวมันเยอะไป เอาไว้ที่หน้าแล้วกันนะ I think we continue next week. I will continue speak of civil engineering for car body design ผมจะพักสัก15 นาทีนะฮะสำหรับเรียนเวิร์กช็อปนะอันที่แล้ว last Tuesday youแล้วอังคารที่แล้วเนี่ยคุณเพิ่งเริ่มเท่านั้นเอง start surface modeling Friday section there are more exercise anyway because last week you have mini project to submit so you don't concentrate more on the surface design I will come back again on surface design you have done for so that you can catch up with the Friday session okay so everybody has computer with you if you don't have you can go to computer center
ถูกเลยเป็นของด้วยกับตอนนี้มีข้าวคือของ
เอาสรุปมา
เกี่ยว
เกี่ยวเพราะว่าให้มันจบ
ต้องมีน้องแตก
Okay.พร้อมยังครับโอเคผมจะเริ่มนะฮะผมจะทวนใน surface design นิดหนึ่งนะครับเอางี้ก่อนนะอย่างที่บอกนะเรามี surface design เนี่ยอยู่ด้วยกัน2-3ที่นะคำว่า2-3ที่หมายถึงอย่างนี้นะจะเห็นว่า mechanical design เนี่ย we do have generative shape design here I mean wireframe and surface design here as well, right? This is also surface design, but we consider this one as a basic surface design, right? The other one is this one. We have generative shape design here as well as freestyle. Okay, freestyle is like a free-form surface design. It's very difficult to use anyway. It's for very complex surface modeling. The other one that we use quite often is this one, generative shape design. We're gonna use this one most of the time, generative shape design. So all the command of the wireframe and surface design, you can see inside this one as well. Let me go to this generative shape design, right? Okay. Actually, generative shape design, this one is surface design. You have the menu, something like this one. Okay. If you switch, you can switch to wireframe and surface design. You can also go to switch to this one. So this is another icon. You see this one. So most of this command you can find in this one, generative shape design here, or the surface design command here. The other one is this one is a freestyle or freeform surface design. It's quite difficult anyway. We're not gonna cover this technique, okay? We just cover this one only, generative shape design, okay? This one that we're gonna use quite often for surface design anyway. Look at this one. You see, you still have you still have find something like a 2D sketch as well. You have 2D sketch. You have some like a feature of this one. So for example, as I mentioned last week, I show you how to generate surface based on solid modelings. Surface model and solid model, the abbreviation are the same. Let me change this one. I show you this one. Let me change this one to example. Surface. See, that part, you see, the abbreviation are the same as a solid model anyway. So you can you can switch back and forth between generative design and part design as well. You can switch back and forth anyway because it's the same format of the files anyway. Okay, I will go back to generative design here. Look at this one. You see, if you want to generate surface based on solid modeling style, you see, as I mentioned last week, you have extrusion here. You have offset here. You have multi-section here. Last week I will show you very powerful multi-section. The number of point of each section doesn't have to be the same number of point. Not like in solid modeling is quite more. That one in solid modeling are more constrained than compared to this multi-section surface of surface modeling. You have joy. You see, you have split. Last week also you show you how to do split, how to do trim, right? What is different between split and trim? Let's see. Let me review a little bit about this one. Let's see if I create a profile, 2D profile here. I use spine curve. Right, this spine curve. We can generate this spine curve. We can extrude this one, right? Extrude the default direction is normal to the plane that you use to create this one, this profile. So you can have limit both of them to, right? This one. The default color will be what? Yellow color, right? As I mentioned, right? And also, let's say if you create a plane, I want to create a plane normal to this, I mean offset from this one. Let's say offset to this one. Let's say I want to get a profile. Yeah. Okay. Let me have this profile here. You can use this one. You can use, if you close this profile, it will be tangent this way. Okay. We have this one. Let's say in this case, actually, you can also, if you want to extrude, you can also do that as well. Extrude this one. Let's say this limit one will be, let's say you put this one into 0, and you can revert direction this one, and you can actually you can use up to neck elements, up to neck elements. Hold on, let me extrude this one. Let me put this one. This one. Let's see, I can put one of them 0. The mirror direction, and this one, right? Is up to limit. You can select this one. Okay, so you can have this one up to this element. Okay, so in this case, you can have element. You can use, if you want to get a hole here, make a hole here, right? You can do both of them by using trim or split. What is the difference between this one? Look at this one. Let's say you have this one, right? This is a split command. This is a trim command. Okay, right? So if you want to look at this command split, actually command split here. Split. They will ask you see element to cut, right? Element to cut is mean which one want to be cut. To cut, this one has to be element to cut. And the cutting element is this one. อันนี้เป็นมีด อันนี้เป็นชิ้นงานที่ต้องการตัด เพราะเราต้องการจะตัดรูนี้ใช่ไหม right? So element to cut in this case, I'm choosing this one. If I'm choosing this size, it means that we want to keep this size and we want to eliminate this side. So we select this one, and cutting element is this one, right? So you have this one, you see. If you say, wow, it's wrong, I want the other side, you can do as well. This one, create this one, or the other side, this one. Okay. In this case, when you do cutting this one using split, these two elements are separate, not combined. Where we have this extrude, we have this one is a split element. That element are separate. It's not combined. Let me delete this one. Okay, do again. Now we are using trim command. Trim command can be done as well. So trim command in this case, both of these elements can be element to cut as well as cutting elements. Both of them can be. In this case, we just select this one and select. I want to keep this one. I want to keep this one. See, and you see you have this one. So you have the same, right? But now trim is a combine of these two entity object, and these are combined to one. Previously, when you use split, it's not combined, it's separate anyway. Separate object. In this case, okay. So if you want to convert this one into solid, as I mentioned last week, you can do by assign thickness. Right? You can assign thickness in there. See? Because this already combined, so you don't have to do any join command. Just go back to this one, part design, and you have thickness here. Command thickness, this one, right? Thickness, and you select this one. So the direction is shown inside there, inside of it. If you want if you accept this one, you can preview this one. It's inside. You see? Okay. So the solid is one. The solid is one. The surface this is one. You can hide this one. You can have solid there. Okay. You can show this one. You can delete this one. Let's say I want to do this one. Okay. You can also assign thickness inside here as well. So you have this one. This is a thickness here. Thickness. Assign this one inside. See, you have this one. Now is purple color. Also, it's the same. But anyway, if you want to modify this with solid command, I suggest you to do thickness at part design, not here. So this one, if you do solid design here, you assign thickness here. When you go back to surface design, part design, solid design, you cannot modify this one. So I suggest you, if you still want to modify, you better to use solid in part design. Assign thickness is part design. Okay. I delete this one. I can delete this one. Okay. You can do fillet here. You want to assign fillet here. You see, you can use this command fillet. You see, fillet, we do have what? Shape, fillet, and a fillet. This one has to be a fillet. Okay, select this one. How much? Let's say you can use 5, or you can increase, let's say 7. Preview this one. You have this one. This one. Okay. You can extend anyway. You see, you have, if you want to extend the surface along this edge, you can do that by using this command. This one, extrapolation, this one. Let's say I want to extend this surface from this edge. Extrapolate this one. Extrapolate which one? I want to extrapolate this one, and you can add this one. See, you can have this extrapolate. You see, and the extrapolate combine. You see, combine everything into one object. You see, you can also if you want to extend this one, you can do that as well. Okay, I want to extrapolate. Select this one. You see, only this portion. You see, extrapolate this one. You see, they will extrapolate this portion. If you want to extrapolate whole edge, I want to extrapolate whole edge. Actually, you can join first. You can join this one and this one together into one object by using this join command. Join this one with this one. Okay. So you have this join edge, right? And now you can do extrapolate this one of this surface. See, and then this one. See? And this one will be combined and join all of them together. See, together. I can. Let's say I do another one. Sketch. I want to project this one onto this one. Projection. I can do projection by using this command. Remember this one. Projection, there are two modes anyway. Normal. I want to project this one. Support this one, this surface. Right? Normal is mean normal to this support. Preview this one. And normal. You see normal to this support. If another one is along direction, it says say you have set direction along set direction. Another one. Preview this one. This along set direction. Along set direction. So either one can be selected anyway. Okay. You have this one. Okay. If you change this one. Okay. Let's say I want to edit this one. I modify this one. This one also modify, right? You see this one projection along set direction. If you want to change this one, you can do just go to this projection and we just normal. So it's normal to this curve. If you look at this one, it's normal. See, normal. ระยะตรงเนี้ยมันจะตั้งฉากตรงมาตั้งฉากตรงนี้นะอันนี้ได้ normal. Okay. So set direction เลยนะ Okay, and you can anyway you can cut. In this case, you can use trim command if you want. In this case, I want to use trim. I mean, split, right? Element to cut. This one, the whole thing element to cut. Cutting element knife. This one will be cutting element. Okay, so you have this one. Okay, so this is the one that I just showed you last week. Okay, the other one I show you few command already. and as well as multi section already. I will show you another one is sweep command. What does it mean by sweep command? Let's see. Shape, geometry, shape design. Okay, sweep in this case is something like a rip command in solid modeling, but sweep is very powerful anyway. Okay, for example, let's see. We do have. Let's say I have this curve. Sweep, right? And also I have another curve. Let's see. Let me use plane normal. I see the plane around this one. Plane normal. Normal to this one. Oops, sorry. Normal to curve. This one at this location, right? This one. Let me draw another profile here. This one. Let's say I want to sweep this one along this surface, right? In solid modeling, we call this one is a rip command, right? This one we call sweep command. See, sweep is very powerful anyway. This sweep command, there are many options here. I will just stick with the very basic one first, with reference surface. You see, they are asking for profiles and guide curve. I said I want this one to be my profile, this one to be my guide curve, right? And you have this one, have this one. You see, you can have this one. So this is the way the sweep is doing by default anyway. There are many options anyway. I will go back to this one later on, but I just show you very basic commands like a rip command in solid model. Okay. Okay. You can actually, if you want to extend, you can also extend, extrapolate. You see, extrapolate this one, this curve, this curve. See, you can do that as well. See? And this one also, if you want to join, you want to do both of them together, you need to join them first. This one with this one. Okay. In this case, you can do extrapolate this one. This surface, this is curve. See? This one. Okay. So this one. Okay. This is just review last week. Let me show you another one. Okay, I give you some time to do this for 5 minutes, and after that, we start with this one. As I mentioned, I give you a more profile here in the backboard. See, backboard here. We give you this one. Let's see, the mouse profile. This one, you download this one. This is a file. You download this one, and you can call up. Have this one, this file. Okay. You can download this one. Workshop surface modeling. This one. This one. Sorry, this one. Profile. You have more profile here. See. Okay. This one. You can download this one. Okay. And after that, you have this one. You have this file. I want to create a mount like this one. This one. ทำยังอ่ะยังไม่ได้ทำใช่ไหมกลุ่มของค่าย Okay, so you can try first how to generate this mouse profile, something like this one. This one from this mouse. Actually, this one is come from K models. Not K model. Actually, we have mouse, and we just digitize point. I connect that point together to obtain a profile like this one. So all these profile are 3D profile anyway. This point also is a 3D point. It's come from digitized device. And after this, we will want to generate this one surface so that we can get this one. Okay. ลองดูที่มีไอเดียยังไงบ้างเดี๋ยวผมทำให้ดูนะแต่ว่าลองดูก่อนลองดูที่คุณจะทำไงหน้าตาเมาส์มันควรจะเป็นแบบนี้นะก็คืออาจจะเฉพาะขอบก่อนยังไม่ต้องดูร่องมันเนี่ยอาจจะเฉพาะขอบเนี่ยนะลองดูนิดนึงรายสัก10 นาที5 นาทีเราใช้ตัวนี้ถ้าดูนะเราใช้สวีปตัวนี้ตรงนี้กับตรงนี้ we use extrude ตรงๆเลยในแนวแกน Z เนี่ย extrude อันนี้ก่อน extrude เห็นไหมนี่ขอบนี่อันนี้ขอบนี่อันนี้เป็นไงฮะเราสวีปเส้นนี้alongอันนี้เราก็ได้ผิวตรงนี้ใช่ไหมเราต้องต่อผิวหน่อยต่อผิวนิดนึงต่อผิวนิดนึงนะฮะลองดูลองทำดูเดี๋ยวทำให้ดูฮะ